So a quick introduction for those of you who don't know me. My name is, on the screen, it's Alisdair Meredith. I currently work for Bloomberg, and I'm also the Library Working Group Chair, which is where I picked up most of the ideas I'll be able to talk about for the next hour, because I've been involved in some way, shape or form with the evolution of most of this. And the intent of this tour is just to say, bring you up to speed with where the standard library already got my bias exposed, where the C++ standards process has got to, and therefore where it's going. So the essence of what we're talking about is, I don't know if you know the famous quote from, I think it was German politician Bismarck, those who appreciate laws and sausages, neither of them should see them being made. And I'm afraid the C++ standards process, to an extent, is a similar kind of vehicle. If you care greatly about your standards, you might not want to see the fine detail of how we go about the process of what comes out the far end, but we're going to talk about what's coming out the far end today. But the inputs are, we're a committee organized under ISO IEC rules. Big reason for this is so that a bunch of different companies can get together and collude to come up with a standard so our software can all interoperate. That's kind of important. And if we don't do so under a standards body like this, we're subject to various legal authorities saying that's a monopoly, a consortium or something, and we don't want to be having crazy rules that stop us actually advancing software. So convening under the ISO IEC rules is kind of important, and it also brings some of its own baggage, such as the pace that the standards can come out and the process that we go through to achieve standards. Just quick for anyone who wants to catch up with where we are. My standard way to find out where's our website, I can never remember the URL. I just type WG21 into Google and that will get me there faster than trying to remember the long thing to type out. In general though, something we've added in the last couple of years, we've got the new website isocpp.org, which is now kind of the community site for C++ in general. The group behind that are also the group behind this conference. So in general, this is probably should be your first port of call for trying to follow progress as to the direction and future of C++. Quick presentation of how we got to where we are today. If we look back at the history of the C++ standard, 1998, we finally published the first standard. Process, this was before my involvement. I traced back through the mailings to see how many meetings were there. It was a process that took about 7 years and roughly 21 meetings of the ISO committee to produce that document. And that was a huge piece of work, because that's from a standing start. You now have to standardize the whole of what people expected the language to be back then. And there was quite a lot of evolution during that process. The template system was substantially redesigned to become much more powerful. Namespaces were created and introduced. Exceptions, I think, were an early part of this process. So an awful lot of work went into getting that 1998 standard, at which point there was a big moratorium saying we need time for people to catch up. So for the next 5 years, and again there was a slight misunderstanding of the ISO rules that people thought they weren't allowed to work on the document. It had to be stable for 5 years, but it gave us a good time to just catch up, have the implementations catch up, and this was effectively bug fix mode. So 2003 we get a revised standard, Technical Corrigendum 1, it's sometimes known as TC1. So over the next 5 years, far fewer meetings. And this is roughly where I come in. At the end of TC1 has just been published. I'm completely oblivious to the history of all this. I come in at the start of the next, what turned out to be 8 years and 21 meetings to go from the 2003 standard to C++11. And this was certainly never intended to take 8 years and probably not 21 meetings. But it turned out, kicking and reinvigorating the process to get going again, it took a little bit of time. And we had an awful lot of features flying around at the same time, and it took a while to actually start landing them into the document to have something to ship. And then all of a sudden, there was an awful lot of integration concerns where did the features integrate as well as we thought they did. So it took a fair amount of time to actually stabilize and give us the 2011 standard, which led to some concerns at saying if it took us effectively 8 plus 5, 13 years to get from 1998 to 2011, where's the next standard going to come from? And it turned out we managed to get another one out. I believe, with Scott, I'm not entirely sure where we are in terms of publication. I thought we'd decided it had just gone rather than hadn't, but I'll have to go back and check my mail. 3 years and 6 meetings. We managed to turn around the 2014 standard very much more quickly. And this is a sign of the future. After 2011 went, there was a concern about how quickly can we ship a new standard? We don't want to be spending all this time. And as we were asking these questions, suddenly we were invaded by a whole host of new people who said, wow, C++ is alive, you published a new standard, you're doing things. And suddenly there's a lot more involvement in the committee and a lot of new ideas coming in again. And thankfully a lot of younger blood, which shows, when your committee is slowly aging, there's a concern that, are we just going to age out and then the language goes with us? So it's very exciting to see a lot of new people coming on board, getting involved and pushing new ideas without the conservatism that leads to a 13-year standard evolution. It's, why are you taking so long? Let's just do things. So this is exciting and scary at the same time. So we've gone from the idea that it takes 3 years to get 8 years, 7 years to get a major standard, to now we can do it in 3 years. And we're trying to do it at 2 meetings a year rather than effectively 3 meetings a year, which is, again, it's an interesting thing balancing our workload. I'm not entirely comfortable about doing it with so few meetings a year, and those are kind of creeping up again. But that's the background of where we get to today. How is the committee organized? Traditionally, we've been 3 working groups. The core working group took care of the first 16 clauses of the standard that define the language part, what the compiler has to do, how it parses the syntax, and what the code means. Library working group worked on specifying everything that went into the library clauses, 17 through to 30. It's sad I've got these numbers memorized, I know. So all the library features. And again, they were responsible for designing the libraries as well. Meanwhile, we had the evolution working group, which convened for the first time at my first meeting back in 2003, this is the group that's thinking for the future of the language and trying to distill the new ideas, and essentially that's working on new ideas for language features. Whereas the library evolution, the idea of evolving the library, has been part of the library working group. And we hit a problem that with so many new people coming in, the easy thing to contribute is libraries. The thing we are generally agreed to be most deficit in is we need more libraries. So there's suddenly a huge manpower of people coming into the library working group that I'm chairing at this point, and we're going to spend almost too long in admin just trying to cope with all the ideas coming in, but we're never going to get anything published. So one of the first changes we've made is we now have a library evolution working group, which is responsible for processing all the new library proposals as they're coming in, similar to the evolution work group has done for the core language. And then once the feature is fully baked and ready to have the wording reviewed, can come onto the library working group. So to an extent, we've parallelized by a level of 2. We've got an extra pipeline we can be pushing work down now, but you've got to come out of one pipeline to feed into the next. So we've lengthened our pipelines a little as well. So we can do more work in parallel, but it might take a little bit longer by a meeting or 2 to get the work out the far end. That's kind of the idea of how can we keep advancing the work at a reasonable rate. Sorry, I'm talking fast. Last time I gave this presentation, it took about 2 hours, and I'm now trying to cram it down into 60 minutes. So we'll see how that goes. So general organization that we have now of the way the committee works, we've got the core and library groups who are responsible for reviewing all the standard wording, what actually lands in the documents themselves. They're responsible for broad consistency across the language as a whole. And they decide when that feature coming through is now ready to publish and land in the document, the work is done. On the other hand, the evolution groups, this is where all your new work's going to land first of all. They're going to review all the new proposals. They're responsible for the direction the language is going to take in the future. They decide when the proposal is complete and ready to move on to the core and library groups. And fundamentally, these are going to pick the shipping vehicle. So generally they're saying, I'm trying to go into that standard, or we've got a new category of vehicle we're now working with, the technical specification, which is a place where we can test new features out before they land in the main standard. So again, this is part of, going to talk about those shortly, a way we can try and ship more features sooner to get more experience, to have more confidence before we drop them into the standard itself. Again, trying to achieve faster iterations. And the next thing we discover, of course, is this is still four broad groups for an awful lot of people trying to get a lot of work done. So we come up with a new concept, which apparently is another part of the ISO working group, ISO process, called study groups. A study group convenes outside the ISO process, so more people can contribute it who are not directly involved in the ISO committees. but these don't produce any ISO work as such. They're going to study a topic and then feed work back into the ISO process of those other 4 groups. But with their areas of specialization, they should be able to work much more quickly to produce much more focused products. That's the intent. The first study group we have is study group 1 on concurrency. Was effectively convening and working all the way through the C++11 process. This was a very key part of getting C++11 to ship. We thought concurrency was probably our largest feature, and we were very lucky to get Hans Berb, who could chair that, and he's agreed to continue on that in that role, working with study group 1 was officially convened as a separate entity to continue pushing our work on concurrency going forward, and that's probably larger than most of the existing standing working groups now, because this is a very exciting place to be. As soon as 11 went out, and we said we need to have, there's a few key areas of competency we want to make progress on reasonably quickly. So we've got a study group focused on trying to get a module system, a study group on trying to do file system libraries. Networking was seen to be a very important area, and there were group of folks working within SG1 on transactional memory said that this was distinct enough, it was probably worth a study group in its own right. So this all came about at the first meeting after we opened ourselves up after C++11 to say, how can we do more work going forwards? We happened to have the largest meeting that we had up to that point with over 100 people turning up. This was clearly because it was an exciting time to be working on C++. We're just reopening all the doors to say, let's start looking at this, and nothing to do with the fact the meeting was held in Hawaii. So the next meeting, we've still got more people turning up. People are wanting to work on a lot of new things. And now we're up to 13 study groups very, very quickly. So as you can see, the idea is people really want to do a lot of exciting new stuff with the language as we're going forwards. I'm going to color code those quickly, briefly. The ones in green are already trying to ship a new technical specification or some other works, for the standard. The ones in yellow either have a document shipping in some form or will very shortly be shipping something to ISO to say, please bless this document, we have something for you to work on. The ones in white are on a slightly longer schedule. They're studying their topic, but they've still not brought anything up to us yet to say, and now we have something we think you should be looking to publish. And we have one study group that, unfortunately, I'm going to go through each of these in turn. The database access study group has floundered for a lack of a champion who's actually able to attend the meetings. So there was a lot of interest outside of the WG21 committee for database access. The overlap between people who wanted to do the work and could attend the meeting was so small we couldn't really honor that under the ISO process. So that group will probably still throw work at the library working group over time, but it's no longer convening as an ISO study group. So, SG1 concurrency. This was an outshoot of the study group that was doing all the work on trying to stabilize the memory model for C++11 and provide the basis of library clauses 29 and 30. 29 is all the atomic operations, and 30 is threads, locks, futures, all the higher level components. For C++14, they have added a shared lock facility contributed by Howard Hinnant, who's sitting towards the back of the room if you want to go say thank you. Sorry, Howard, you're going to get stuck with this. And ongoing work looking at C++17 for additional changes to the basic locks, traditional threading primitives, and some higher level libraries built on top of that. So I spoke earlier, we've got this notion of a technical specification, which is a way we can kind of ship a beta test of new library or language features. And SG1 has already initiated 2 technical specifications, which they've broken the work down into 2 broad areas. Concurrency, which is doing lots of different tasks concurrently at the same time, which is a good way of reducing latency, for example. And parallelism, which is splitting one task to be computed in parallel to bring together a big result at the end as quickly as you can get it. So trying to break down the different notions of concurrency, which tend to have very different design spaces about how you tackle the problems in this area. So each one of those is having its own separate TS. The parallelism TS is actually already out for its first ballot, and the concurrency TS is probably a meeting or 2 behind. SG2, modules. Another broad area that there's an awful lot of interest in this, but it's a very awkward area to get right. The basic idea is when you're trying to build large, complicated software, we're still carrying the legacy of 1980s C, where you assemble your large software with a hash include that just prepends all the source of many files into one big translation unit, and many of these files are passed over and over and over again, especially as more code starts ending up in header files, because that's where all your template definitions end up, and that's where a lot of your inline functions are going to appear. So it's known that using the preprocessor to do this is not the ideal solution we'd like to be working with. And many of the languages don't have this problem. How can we produce something that's a more modular way of building, separately compiling lots of parts of C++ and then bringing it all together at the end? So modules is the broad notion of this. There's also the idea of runtime distribution, as do I put this group of code together, ship it as a module that then my linker can see and say I can find the symbols that are in there, and then when I deploy the system, that's the same code that I deploy against. So that's also part of the same design space. I'm not yet sure what's going to ship from this study group because they're still looking at the problem. There's a lot of prototype work occurring through Clang. And as of the last standards meeting, we can see there's a lot of interest from Microsoft because Microsoft have come up with their own proposal. And there's 2 or 3 proposals that are all broadly in the same space here. I think the Microsoft proposal was largely to say, this is important that we ship something, so let's really push and actually have a concrete proposal people can be working on and giving us feedback on now. The essence of most of these proposals is something like very fine-grained precompiled headers. So assume we're all familiar with the notion of a precompiled header to accelerate the builds. You see a series of includes, you precompile them once, and then I can just include that precompilation of that sequence of headers. It tends to be fairly fragile. It tends to require, for instance, the same sequence of headers in exactly the same order that you then have to expose to every translation unit, whether or not they need all of those headers or not. So modules is trying to, with, as I say, fine-grained precompiled header, almost precompile each header in turn. So you end up with something much smaller and much more granular that you can assemble this way, ending up in some specific kind of additional pre-translated form. A big benefit you're going to get from this is macro installation. So because you're no longer having to prepend with a hash include all the code assembling all the time into one big translation unit, macros don't leak as far as they used to. When you build software in the new scheme, that we still have to somehow make compatible with the old scheme. Hash include doesn't go away. It's there for compatibility. It's how people know how to build large systems. They've been doing it for years. It's not going anywhere soon. But once we can transition to something along these lines, we expect that macro pollution will be much less of a concern than it is today. And there's a hope that we might get something for separate compilation of templates. Not clear that that will fall out yet. Some folks are more concerned about trying to deliver that than others, but it's in the space that this study group is looking at. Unfortunately, as I say, we have nothing to report about something that's shipping yet, but hopefully within the next 12, 18 months, we'll have more to say here about something concrete being proposed. Study group 3, file system. Again, this was one of the first 5 study groups we created. This was proposed because we had a very specific problem we were trying to solve, and we got a very specific solution already in the works we could look at. So with the classic C++ standard library, we can open files, but we can't find files. We can't traverse the file system. There's an important abstraction in the application domain that we need to get to build useful tools that we can't do portably. So the file system library tries to get to the notion of directories, traversing directories, finding files, asking about the properties of files. It's a proposal came from a lot of existing practice. Beam and Dawes piloted this all through Boost very specifically with the goal of having something that could go into the standard one day. So it was created in the first place hoping to land in our group, and we've now taken that on board, very much thanks to Beeman, and written in a manner that would be amenable to becoming a specification. So finally it landed in the committee, and the first thing we do, of course, is rip apart the wording and say, no, this is how you want to say things. And Beeman was very glad for this because that was the goal that he wanted. So what we end up with has been a cleaned up specification. It says things much more precisely, and the library interface is largely the library interface that came out of Boost in the first place. I don't think there were many changes made to the actual library interface part of the specification. And sorry, that I'm already talking about 10 slides ahead where I actually get to talk about the specific TS. So that is now it's in its final ballot. I don't think we've got the result of that yet, but that's the yes or no. We're not going to make any more changes for the document. When that ballot passes, hopefully soon, that goes straight to publication. So this is our most advanced TS net in terms of the ISO process. We should have this by the end of the year. But at that point, this was why SG3 was convened, was to get that TS published. And one of the interesting things we found from the feedback was people want more. There's still more in this area. We didn't want to hold back the TS to get these other things, but there was a lot of interest from IBM. We're very interested in having a portable API to talk about much larger enterprise scale file systems, clustering file systems. There's some interesting work that we expect to see there in the future. And from a different perspective, Google were giving us some very large concerns that we specified ourselves on an older POSIX API that had certain security vulnerabilities. If you were being very cute about, okay, give me this file name, now open the, find me a temporary file, then open that file. And there's a hole in the middle where a skilled attacker might be able to intrude on your system, and we would like to close those holes. So there's a definite concern that we might be able to do something better in this domain, but given we didn't have an actual proposal about how we should be doing that yet, we didn't want to hold back this important facility that is no worse than the existing practice and really opens it up to C++. So that has gone forward, but we're definitely expecting to do more work in this area in the future. So SG3 is very much an alive and ongoing piece of work. SG4, the networking study group, has had something of an interesting history. This was another study group that was given a library almost fully formed. Back in the dark early days of the library evolution, around about 2006, 2007, we were trying to get another library TR. Following TR1 was our initial exploration of additional libraries that folded straight into C++11. We were working on another TR back then that had the file system as a proposal, and it also had a networking proposal built upon another Boost library, Boost ACO. And we were at the point we were about to accept that when we said, it's really important that we ship the C++11 standard that we were still calling C++OX in the hope that X was not going to be a hexadecimal digit. Little did we know. So at that point, we put aside all work on new libraries until the C++ next standard shipped, which was, we were hoping in another 2 or 3 years, and it was probably another 2 or 3 beyond that as well. So once we reconvened, we said we'll have the file system TS can ship the file system work, and the ACO was a much larger project. It was an important thing to get into to solve, portably expose the ability to communicate over networks to the C++ language. This is a very important domain. And given there was a large library proposal there, it was also suspected it would require a broad number of changes to look more like a modern C++11 interface. So it was reasonable to convene a study group to work intensely on this. What we didn't expect was a much broader community of people interested in networking problems came on board to say, great, we've got a study group to solve our problems now. And the first thing they said was, ACO is a much bigger thing than we want to swallow whole. So we're going to take a much more methodical process. We're going to iterate and carve out small bits and solve problems well and iteratively try and build year on year. We'll keep doing, say, 1 TS a year, and we'll build a much more coherent library this way. And unfortunately, in the intervening years, interest and attendance of that study group has waxed and waned, so it hasn't advanced quite to the level we expected and hoped. So we've got one API, the network byte order API, which was supposed to be shipping as part of the first networking TS, has now been moved into the library fundamentals TS to make sure we had this work that was ready, that we didn't hold it up for this. And now it looks like we might be considering going back to the original idea of, let's see if we can swallow ACO whole and get a large, consistent solution to the problem. And it's shipping as a TS. It's not binding on a future standard. But by shipping a large, coherent, self-designed, self-consistent library designed in one place, hopefully we'll get some feedback as to what the future direction should be. And we can get something out much sooner, which is the original goal of the TS. So it's not clear that that's what's going to happen, but that seems to be the intent going into the next committee meeting in a couple of months. So SG4 very much in transition at the moment. but still definitely trying to move forward. SG5, transactional memory, has now actually had its new work item ballot come through, so ISO have officially said there's going to be a specific TS coming on transactional memory. This group has made significant progress, and we expect to be looking at a document for this TS probably at the next meeting to say time to send that on to ISO for the first round of balloting. Transactional memory is a different way of approaching a lot of the problems of concurrency, where rather than specifically managing your locks and contentions and mutexes yourself, the idea is we go to a more database-like model. I will just assume that my transaction is going to succeed. I'm going to say I've got a transaction here. I'm going to do some things with some possible shared memory, and at the end I'm going to commit that work. And if nobody else has modified that memory in the meantime, great, I succeeded. And if there was an intervening right to that memory or access in some way, well, that means that my attempt to write to that memory is going to fail. My transaction hasn't been suitably isolated, and I'm going to have to try again. And it's coming up with some language and library abstractions around this. There's a concern, it's a different model of trying to approach concurrency, but it leads to code that's much simpler to write because you're not explicitly managing down at the level of locks and threads and data races yourself. That's all completely abstracted away by this memory model. So it's a nice thing to get if we can make it work. This is much more of I would say it's more of a blue sky area. The people who are working here going, no, we've got a lot of experience in this space. That's why it's coming to you now. So be interesting to see how this actually lands and merges with C++ as a whole. There's a lot of concern that it's potentially expensive without hardware acceleration. GCC is now shipping with an awful lot of these facilities, certainly with software emulation, and on platforms that support it, I think we now have the hardware support as well. And the hardware support was something that was spoken about for a long time in a lot of the Unix systems, but even Intel are now shipping it as part of Haswell. So hardware support has come to this just around about the same time as we're getting to the point to say we really want to examine this area. So interesting things happening in the world of transactional memory, and this study group is probably about to deliver something really big and important for us. Next study group, numerics. Again, different domain of interest. There's lots of long history of C++ being involved and used for numerical work, largely because we're a high-performance language. Going back to the original library TR, we had a large component of that was some additional scientific and engineering math functions that unfortunately did not land in C++ 11 for a very interesting reason. The library working group said, yep, this is great, we've done the work, we want to ship it, we put it up to the full committee, and we got some immediate kickback from folks like Microsoft and some of the other large vendors saying, yeah, I can see you've got a full distribution of this available in Boost. The licensing is free. We're able to use it. We can pick up that documentation. It's going to cost us no work or very little work to simply adopt that thing from outside if that's how we wanted to incorporate this into our product. It's still too expensive to us for a simple reason. If we ship this under the Microsoft banner, we're going to have to employ postdoctorate mathematics specialists to sit on the helplines when someone phones up with a bug report. And finding postdoc mathematicians who want to sit on helplines is not an easy task, and it's not the business we're in. So no, we did not want to see that in the main standard itself. So that work then effectively shipped out. We now have a separate standard on math bindings, so that there's still an ISO standard that people can code against. And certainly some libraries are very happy to sell you that. And as I said, there's a full implementation in Boost that conforms to that standard interface. But we know we've got an awful lot of interest in doing more interesting things in numerics. So there's a study group focused on that. And there's a couple of ideas they're looking at. One of the other features that went out for a separate TR in the pre-C++ 11 days was work on decimal floating point representations. This was, again, another interesting topic that came through from IBM, who looked at an awful lot of what their big mainframes and large servers were doing, and they said, they're in the financial industry. And lots of these folks are dealing with numbers that have decimal representations, and the majority of our CPU cycles are spent converting between binary and decimal backwards and forwards again. Why can't we just do everything in decimal? And they actually ship decimal hardware to make this practical. And so we adopted a TR for that would give us decimal floating point to go with the binary floating point that's in the C++, the original C and C++ standards. And it's time to pick that work up again and see how we can integrate that into either some C++17 future standard or a separate TS. So this is something that the Numerics group's looking at. And we've had a couple of other ideas coming for this study group. So unbounded integers are another common feature request. They're a very common problem that you give to undergraduates to just understand how to build numeric systems. It's a very easy problem to deal with. I'm saying, if it's such an obvious domain, why isn't it part of the C++ standard already? So we've got proposals to look at that, and rational numbers, which you then are much more interesting when you can build them on top of unbounded integers. A very interesting fixed point binary library coming from Lawrence Crowell, which again, at compile time will just deduce longer and longer binaries for you, and then the idea is at the end, once you've done your computation at full precision, you can normalize back to a more useful vocabulary type, so you're not generating infinite types throughout the whole of your software. But interesting way of trying to preserve accuracy through your computation before you then round back off to your final result. And again, we have a very interesting random number facility contributed to C++11 that is very composable. So now that we've got this composable system, we can have additional random number distributions, additional random number engines to generate the random bits for you. So there's a lot of interesting work for the numerics folks to be looking at. But other than the decimal floating point, we don't actually have something likely to ship from them coming in the next meeting or two. But I believe they're getting close to shipping something based upon this feature list here. Reflection working group. This is a feature of many other languages, and it's known that in C++ we would like to do more in terms of reflection. I'm going to assume that people are broadly familiar with the term reflection. We're introspecting our program either at compile or runtime to find out properties of functions and classes, to therefore try to make our program adapt to if you've got these features, go off and do this thing. If you've got these features, do something else. So we can query our program at runtime or compile time, because C++ has this wonderful compile time, runtime divide where we try and do different things at different parts of the system. And any interesting new features that might impact the idea of reflection tend to go through this study group. One of the big problems reflection faces is if you want to do runtime reflection, it's potentially very expensive. People already like to turn off, if their compiler has an option to turn off runtime type information, and reflection needs something much, much richer and much, much larger than is already present there. On the other hand, there's a real desire to do this, and some people are prepared to pay that cost, and we would like to do it in a standardized way. So this is the study group focusing on anything that's going to hit this domain. And in addition to, say, runtime reflection, you've got compile time reflection. Give me a list of all your elements as a tuple to a class. These kinds of features. So lots of study been going on. I believe, I don't see Chandler in the room to tell me where they're up to in terms of progress, but I believe that first couple of actual proposals to come back to the committee are expected to be emerging in the next meeting or two. So some concrete work is finally emerging from this group. So exciting things in the near future, but nothing specific to report from reflection quite yet. Study group 8, concepts. Anyone who was following the evolution of what turned into C++11 will know that an awful lot of work was sunk into the language feature of concepts. So quick show of hands, if I talk about concepts, is anyone familiar with what I'm talking about? Okay, there's a fair show of hands in the room. So for those who didn't quite follow along, the idea of concepts is almost a type system for the parameters within templates themselves. So where we can constrain and talk about templates using type-like language that we use for regular functions. And there's all sorts of wonderful things follow when you can do that. And we had an awful lot of fun exploring that and building a larger and larger feature that was going to solve more and more problems. And it became very hard to solve some problems because many problems we could propose to say, but that would be solved so nicely with the concepts feature that it absorbed an awful lot of different problem domains. And eventually we built something that just, every time you poked it from one direction, something else fell out somewhere else. And it just wasn't coming together fast enough to be what we could ship in C++11. So we deliberately took it back out of the working paper and said, let's trim this down and come back with something lighter that works, and then we can hopefully in the future build back up to being the larger, broader feature that we want to work on. So that's what Study Group 8 Concepts has been working on. And we're going to talk about it later, a very specific proposal now for a new TS coming out of Study Group 8. It's not quite at the point it's in front of ISO to ballot, but we expect to be sending that out probably at the next meeting. It's come very close now, and we're calling it Concept Lite. So it's the cut down version of this feature that we can then build upon in the future. Specifically though, that's just the language proposal. Part of trying to simplify features is we've cut it down to see if we can get the language right. We can then build the library on top of it. So we're going to have the separate follow-up to do the library proposal using the Concepts Lite feature. And because this is a TS and not shipping directly in the standard, it's much easier to do this incremental approach, which is why moving to the TS vehicle has actually been very helpful for breaking log jams in the process. Yes?
Have you had a precedent for having to back off of a TS yet? Say you go down to Boost as AO and you have to back up, or you go to ship the concepts library and you have to back up. What's that going to be like?
So the question is, do we have we any precedent of shipping it, trying to ship a TS, and then deciding it hasn't worked out and backing off from it? Not as such. I'll give a couple of examples that are kind of in that space though. With the original library TR1 that we did back in 2005, 2006, as I said, the special math functions were a part of that TR that didn't fold into the subsequent standard. But they were still deemed important enough, we created their own separate international standard to hold that work. So the work still continued. Another example I alluded to a couple of slides back was the decimal floating point work, where we had a decimal floating point TR that it was out there, but it wasn't eagerly picked up. So it was just kind of sitting out there withering on the vine. But the interest has come back into that area, so that is still being picked up to go forward. We might talk about, I guess, if we look at another TR we shipped back in the C++03 days was the performance TR, had a couple of headers for directly talking to hardware, and there hasn't been much interest in picking that up again. But it still is part of that existing TR document as long as we keep renewing that TR, saying, yeah, all the things we said about performance back then are still as true today as they were back then. We don't plan to update that TR because it says what it wanted to say. They will still be available through that TR, but they seem to be very interested in bringing those forward into the next standard. We've had a fairly good hit rate so far with work that has gone through the TS process, but we're now exploding into a much larger number of TSs, so we're probably going to have less of a positive hit rate in the future, but we don't know when that's going to kick in. The hope is we can be more experimental in this space.
Well, I had some comments on that, but you've pretty much covered it.
Oh, thank you. So I have 20 minutes to go, so I'm possibly still on schedule, because I do want to talk about the TSs that are coming as well, because that's where we're actually going to give you something. But 4 or 5 more study groups to go through still. Rangers, Marshall, this is your baby. This is a study group that's not suffering from a lack of proposals, it's suffering from a wealth of ideas and trying to distill from this which ones we want going forward. One of the first observations most people have when they look at the C++ standard library is the fundamental abstraction of the library appears to be iterators, but in practice it's ranges, because the iterators almost always come in pairs. So why is the library not actually using the fundamental abstraction, but using this crazy iterator thing that comes out on top of it? And we get lots of proposals therefore of how to write a much easier to use, much more composable standard library using ranges. But ranges mean different things to different people. Should you be able to traverse and iterate through the range using something like an iterator? Or is the range itself a fundamental entity, so your algorithms take ranges and return ranges? Which becomes, interesting question of, what's the result of sort range? I think probably should be asking, what's the result of a find operation? Do I get back an element, an iterator into an element, or a range of just one element? Depends very much on your mental model of what the range concept really models. We can also generalize the notion of an iterator pair. Do the iterators both have to be the same type? Or can I have, I've got an iterator and an end condition. If I keep iterating and as soon as I hit the end condition, connotes the end of the range, which is especially handy if I'm trying to indicate infinite ranges. So there's an awful lot of interesting problems in this design space, and trying to distill out the one true answer to have something that goes forward is thankfully Marshall's job. Actually, it's Marshall's job to referee. The actual job is the work of this study group to bring their ideas together, discuss, and hopefully between them distill out what we figure the right way forward is going to be. So again, very rich, fertile area, too rich, so this one's not actually got anything that's, as far as I'm aware, shipping in the near future. But still making progress. SG10, portability. This was an interesting problem that once C++11 became a standard that we could start talking about and shipping, lots of compiler vendors start implementing these different features, but they're implementing them at different rates. So we end up with lots of different dialects of C++ and trying to ask, is this feature available to me or not? And I start embedding all my code with lots of, if I'm on this compiler, I might have this feature now if I've got this compiler at this level. And it becomes very hard to write code in this environment. So there's a notion that maybe if we could standardize the process that we can report and query the compiler just to say, do you have this feature implemented yet? That's a part of the new standard. And the compiler can have a yes or no. So some kind of macro-like feature to say now, do you have this feature available? This was effectively the end result of the portability group saying, yeah, we've got to have a standardized way to get here, but we never want to publish this as an ISO standard. Because if we start endorsing these as part of the standard document, what we're doing is immediately fragmenting the language and saying all these different dialects supporting the power set of which of these features are available or not are all different official ISO C++ dialects. We do not want to say that. But it's still an important problem we need to solve, because people are writing code in the transition period from 03 to 11 where the features incrementally become available. So the notion here is we've got what we're calling a standing document. It's something we're going to be publishing on the ISO website, and probably you'll get to it through the ISO CPP.org website as well. And this is a suggestion to compiler vendors that, if you want to be friendly to your customers and let them figure out, do you support this feature? You might happen to have a feature just like this that I now believe all our compilers are moving forward to be able to support in their current iterations. Still doesn't help you with the history of all the compilers before they got onto the new feature, so there's some aspect that there's a transition that has occurred. But going forward, we should now hopefully have an easier way to portably deal with code during the transition from when before a feature was available to when it was available, if we're trying to eagerly adopt and start using it and hopefully get some feedback back to the committee, even during the evolution phase. So that's essentially all I've got to say about that study group. You're going to find they're now regularly shipping a standing document. Most times we release a new mailing from the standard, which is every 6 months or so. There'll be an updated version of that standing document. Study group 11, database access. Again, this is a huge, important area. If you're trying to be a modern language, the vast majority of data that's being stored these days is stored in a wide variety of databases out there, and we want to have easy, portable ways to get to it. Most of the languages have a standard database access API that the database vendors know you provided a driver in such a way that you can get to this. And there is no standard portable API for C++. The majority of vendors don't care about providing a standard portable API to C++ because once they've provided their own dialect to get to C as a high performance, low overhead way to get directly access to their database, that's also callable from C++. It might not be idiomatically the way you would use those features in C++. You don't have things hidden behind constructors and destructors, so RAI is taking care of all your lifetime issues for you, but the job's done. So it would be very nice to have a standard portable C++ interface in this space that might not be the most high performance way to get to your database, but is fairly portable, and you can maybe move between different databases, move between different compilers, and write something in an idiomatic C++ manner. But the trouble here is study group 11. We've got a limited number of people who are active and working on the committee. And although a lot of people think this is a really important space, it doesn't coincide with the space an awful lot of people on the committee actively work on day to day. And of those few who are, they're already actively interested in some of these other study groups. So although there's an awful lot of interest in this, and there was certainly a lot of people outside the committee trying to involve in the study group process that happens outside of ISO, the one person who could chair this study group and represent it to ISO is no longer able to attend all of our meetings. So unfortunately, this group has now been dissolved as a separate study group, but we're not saying we're not interested in work in this area. What we are hoping is people who are working in this area will feed back regular library working group proposals into the regular library working group process, because we still have the library evolution working group. These groups do not replace the library evolution working group. These are just a place you can do focused work to hopefully make the library working group, evolution working groups work simpler, because the proposals that come to them are more fully formed already. So essentially it's more nebulous that it will come to the library evolution working group, but we don't have this fast track anymore. So if you're interested in this area, please do get involved, do contribute. If you want to start getting involved in the standards process itself, maybe you can help resurrect this group because we know it's important. But at the moment, this is no longer happening within the ISO process itself. So study group 12, undefined behavior, is a favorite topic of many people. Some people are concerned that there's undefined behavior is a horrible thing and should just never occur in the language at all. One of the interesting achievements of Java that they promoted from early days is they have a language that has no undefined behavior. There may be some unspecified behavior in Java, but there's no undefined behavior within your program executing on the virtual machine. And I think that was a notable achievement. It's a very good thing in its own right, but it comes at a cost. The undefined behavior clauses in the C++ standard give the optimizers great opportunity to reason about what a valid program is going to do and just rule out crazy cases it doesn't need to worry about and support anymore. But there's a concern that if you don't know all those corners of undefined behavior, your program is going to catch you out as you go from platform A to platform B in very strange and surprising ways. And is all the undefined behavior that's in the standard really necessary? Classic example from C++ 03 was if you didn't terminate your file with a new line, just a blank line with a new line character, you had undefined behavior. An undefined behavior in any one translation unit, anything including that header, means your whole program has undefined behavior. Because there were a variety of implementations that did different things at that point, and we didn't want to dictate which preprocessors were correct and which were broken, so we just left that as undefined behavior. And that might not be the most helpful approach for developers working in a large system. So the undefined behavior study group is going to hopefully review most of the undefined behaviors in the current standard and say, can we do something better here? Can we delineate maybe just a few well-defined behaviors that make sense here rather than leaving people open to a huge gaping void of their compiler can do anything at this point? I really don't want my compilers launching games of Rogue just because I didn't terminate my file correctly. Hopefully, a bunch of you will know the reference that an early version of GCC did detect certain kinds of undefined behavior and did inject calls to the rogue game into your program. So this study group, it's in early days. It's meeting most meetings, I believe, and I expect we're going to be seeing some progress from this, which will probably result in changes to C++ 17 rather than any other TS shipping, because these aren't the kind of things that you can close down in a TS, but they are likely to lead to hopefully a simpler standard in the future for people to try to understand. Which brings us to the final study group. Yay! Graphics and I/O, which is about 2 or 3 meetings old now. Again, graphical input and output is known to be a very important domain. Nobody really talks to their computers in the modern day and age with the command line interface other than us who are writing the programs. This is an alien interface to our end users. But we can't talk portably in any kind of familiar user interface language because the standard just doesn't get there. And it's a very hard problem to solve in C++ because we like to talk directly to the native underlying system. And Unix and Windows and the Apple system and now the variety of smartphone operating systems, they all have very different graphical languages. So how can we write something portable? Well, that's the problem that this group's going to try and address. And even if we can just get down to some basic primitives, so you can write a portable graphic system. It might not be your high-performance native system, but it's really important that we can do something in this domain. And it's interesting, it was Microsoft got really behind sponsoring and pushing this work, and now that they're behind it, an awful lot of other people naturally want to jump in and get involved to make sure that we get something that's going to be hopefully fairly solid, but there's a real desire to deliver. This is one of the benefits once Microsoft get behind something on the standard that has been a little bit difficult to nail down. They're very keen to make sure we actually have something that ships. So a lot of the urgency comes back, and that's an important part of the process. You need to have someone who's got the end goal in mind. So I have high hopes for this study group. Nothing shipping yet, but I think this is going to crystallize very quickly and ship something fairly soon. I'm down to my 10-minute warning, and I've not yet gone through the TSs that we're now going to be looking at. So, moving on very quickly. Basics of a TS. The notion of a TS, technical specification, is it's a non-normative extension to the standard. So we can ship it under the ISO umbrella. We get all the benefits of working through the ISO process. Ship slightly faster than an ISO standard because we save one of the various ballot stages you've got to go through to produce a standard, because it's experimental. There's a little less rigor involved, so we can get that feedback before hopefully feeding this work into a future standard. Some conventions that we've had, because most of these TSs are library TSs. All the new headers you're going to see going forward for a TS will now be an experimental / something library, so you can spot when the header's coming from a TS versus from the standard itself. All the new features from a standard library, a TS library, will be in a standard experimental namespace, and maybe additional subnamespaces beyond that, but at the very least they'll be in standard experimental. And all new libraries, again, will live in a further inline namespace. Inline namespace is a C++11 feature that is going to make it much easier for us to version libraries in the future. So you'll not, in actual practice, you'll not use the inline namespace. It acts as if, almost as if it weren't there. But in terms of the ABI, it means that when we change which inline namespace is the active one, all the old code compiled against the old ABI will still link against future libraries that compiled against that ABI specifically by name, but we can still move our libraries forward onto the new ABI. So we don't have much experience shipping with this yet, but we believe this is a large way to solving the versioning problem in C++. And that's the approach we're taking in terms of all the library TSs going forward. So we'll see how that works out. TSs that are currently in flight. This is the current work queue in addition to C++14 and C++17 from the standard committee at the moment. We've got the file system TS, library fundamentals TS, TS on parallel algorithms, TS on concepts light, TS on transactional memory, TS on concurrency extensions, a TS on networking extensions, and a TS on array extensions. You'll spot I've called this out in orange. This was a bunch of work that was in the initial C++14 draft on the first round of feedback before it was adopted as a standard. There were a couple of language features. There's a language feature in there for arrays of runtime bound, which is kind of like a CVLA, and a library equivalent. But there were a lot of concerns that the library equivalent was specified optimistically about a compiler optimization that we didn't know whether or not we could actually deliver. So there's a request to pull that feature out and say push that into a TS and ship it later once we've got real experience with it. And then another concern that we want the language and the library features to really have to go together, coupled up. So we took the language feature out as well and put that into the TS. And then the language feature that we thought was very stable, very well specified, and completely understood and widely implemented suddenly hit into a lot of trouble at the last standard meeting with people saying, actually, are we sure we even want the feature? So it's less clear that this array extensions work, even though it's passed the new work item ballot for ISO. ISO believe this is going ahead. It's no longer clear that we're going to pursue that to completion. That's an interesting problem for Bjarne and the evolution working group at the next meeting or two. But you can see the rough state of most of the other documents. File systems at DTS ballot. That means that it's going to publish sometime this year, we hope. Library fundamentals and parallel algorithms are at the PDTS ballot stage. This means we've sent them out to ISO to say, we would like to turn this into a TS, please. Goes out to all the national bodies who then get to file back their comments with yes, no, and if I've said no, here's why. Or if I've said yes, here's some ideas that might please clean it up before we do the DTS ballot and clean it up. So we're probably 1 or 2 meetings away from these things being published. We hope to have those ballot results in before the next meeting. Concepts light and transactional memory I have listed as feature complete. It was 50-50 whether or not we'd be sending them out at the previous meeting. There was some concern. There was a little bit of wording cleanup on the standard specification themselves, but we're at the realm of the language lawyer tweaking the specification and the wording of how we say something rather than what we're trying to say. So there's a very good chance that both of those documents will go out to the PDTS ballot at the next meeting. And if not, I really expect them to be at the meeting beyond that. Concurrency extensions, I'm less clear how quickly that's moving forward. It's definitely on its way, but it's still accumulating work. It's not yet feature complete, but we've notified ISO. We're really doing some work here. We have a requirement to start shipping something sooner rather than later. And networking I spoke about earlier, we're probably going to be looking at moving across to the ACO library. I really did want to jump in and actually give you a quick slide on each of these TSs. You'll see we've also got my notion that library fundamentals is at the PDTS stage. We're already sending something out for ballot. We're already planning on shipping the next one to the similar stage on an annual basis. Running forward much more quickly now. File system library, if you know the Boost file system library, you've got a very good idea of what's in this. Key variation from the earlier Boost file system library to the later one is that the file path class is no longer a template. Internally, it's going to store the string representation of your file names in the type that's native to your file system. But the user interface will happily traffic in wide or narrow characters, and it's just a much neater way to get this work done. And this was a big change between the 2006 TR2 proposal. By the time we got around to looking at this again as part of the SG3 work, the file system library had made this change, had got a lot of very positive feedback, so that's a much nicer way to work with that now. Library fundamentals has a variety of classes that most have been experimented with Boost or a few other places. So the optional, any, and string view libraries, I believe, are reasonably well known through Boost. The polymorphic allocators proposal, you'll hear a little bit about maybe on Wednesday if you come to my talk on that. That's something near and dear to the heart of Bloomberg. It's not the topic of my session on Wednesday, but it's a strong motivation behind it. So you'll kind of get it by inference. Boyer-Moore searching is something that, again, Marshall has given us at the back of the room here. I believe that's available in Boost as well now.
It is.
So, and we'll hopefully shortly be shipping from many of your standard library vendors too. The network byte order is H to N, N to H functionality that you might be familiar with from it if you've done any work just trying to make sure that my bytes go out onto the network in a predictable sequence. We've now got a C++ template-based version of those that will work natively with the types rather than go through the macro scheme. We've also got a couple of changes for existing library components. So shared pointer now gets support for arrays. We have this polymorphic library proposal for allocators to say, now I can pick my allocator at runtime. I also want to plug that into all the existing standard containers, which we do in a sub-namespace. So the existing containers can now be used in a PMR namespace that says PMR polymorphic memory resources as a polymorphic version, therefore, of all the containers. And it turns out that's just a type def, an alias template. It's not significant new work. We've got a sample algorithm for data sampling when you're trying to sample values out of a large sequence. And an example in C++14 actually just becomes normative text. Because it was a useful feature. Why did we just make it an example? It's an example of using one of the new C++14 libraries. The two things I have in red are SFINI-friendly iterator traits and common type. These are two type traits in the C++11 library. And there's a suggestion that the way they were worded didn't work very well with SFINI. Therefore, there was a desire to say anything coming new into the library goes through TS. They went into the fundamentals TS. And it was then discovered that all libraries were implemented this way anyway. All that was lacking was a specification that said they had to be implemented that way. So we just pushed those straight into C++17. We discovered this just too late for C++14. But those changes are going to be the first things we vote into C++17, possibly at the next meeting. Concepts light. I have 2 minutes to talk about concepts light, and I can then skip the rest. This is what we end up with, having tried to distill the simple parts of concepts for somebody we can ship in a TS and get feedback from a language feature. So the key changes, we're no longer going to try and concept check the bodies of your functions. It's purely about trying to express cleanly the contracts as to which functions you're going to select in overload resolution and which functions are appropriate. It's essentially a language-based version of something like SFINI that can be implemented much more conveniently and easily at the language end, and is a much easier syntax for you as a library author. The notion of a concept is essentially, it's a const expr predicate function. And there's a new syntax for writing them in a more concept-like language, but any const expr function that returns something convertible to bool will act as a predicate, will be able to act as a concept for you. We also lost the notion of the concept map, because concepts are always going to be inferred now. But we still retain the notion of concept overloading, we just pick the most constrained concept. The tricky part is we've got this terse syntax where I can just use the concept name as if it were a type name as part of my function signature. And that means if I recognize that name as a concept, I will know, I'm looking at a template, even though the template keyword was not used in the declaration. And I'm being told I'm over. So as long as people are willing to give up their lunch, I'm happy to keep talking.
Just a comment, Andrew is presenting on concepts like right after lunch.
So there's a big talk on this session right after lunch. We're going the wrong way. Quick example of what the concept syntax looks like. We've got the concept and requires keywords we've retained from C++11. So we've got a concept declaration, kind of like a class declaration. You've got your body, no trailing semicolon for some reason. I'm not sure why that fell out of the grammar as not being a statement. And again, we can put a requires clause in that says we require these operations are supported and they return these values. So a simplified form of the way we might declare a concept before. How do you use them? This is a slide I want to get to. You can see we're now saying at the template declaration, we can drop in the concept name by name. So that immediately tells you that T has to satisfy the constraint of object, which is the weakest constraint you can give. All I know is it's not a function now. Allocator, again, will satisfy all the allocator constraints because we're trying to write something like a vector and we know vector takes the element type and the allocator. Notice that the vector move constructor requires movable. This is a very hard thing to write with spin-I in C++11 because that move constructor is not a function template member of the class template. So I have nothing to spin-I on. But with concepts, concepts like this now becomes possible to express quite cleanly. So this is a really important part of the space of template design that you can't get to easily without concept light. You can try and emulate this by turning your move constructor into a template, but actually there's always going to be an implicit move constructor anyway, or almost always, how it'll catch me on the fine details, which is going to be called in preference to the one you write. So move and copy constructors have a real problem with this, and the emulation elsewhere is you start writing templates for things you don't want to be templates. And the last example is the range constructor. You can see we're doing the concept deduction to say I've got a template on input iterator and a template on forward iterator. And this solves a lot of the problem about trying to pick up the more derived concept matching and trying to do lots of crazy tag dispatch. The concept system itself can pick out the most constrained concept that you satisfy and will automatically call the right function for you. So it makes writing templates much simpler. If you still want me to keep talking, I've still got another 3 or 4 TSs I can talk about, but I am well over time. So please feel free to get up and walk out at any point. I'm just going to keep talking. I failed to get this down to an hour. Parallel extensions. We're going to provide overloads for most of the library algorithms in the algorithm header and in a couple of the other algorithms in a couple of the other headers as well. The key extension here is we add a policy that describes permission for the library to use parallel extensions to get that result for you. And the key policies we support are sequential execution. Parallel execution means you can spin up as many threads as you like, or potentially constrained, and vector parallel, which is an odd one, but we have some wording here to say I might even have race conditions in a single thread, or I'm not, and how to avoid those, because vector instructions all occur within a single thread. So there's at least 3 forms of parallel policy that might go here. And vendors like NVIDIA might have their own ideas about their own policies they want to put in to additionally enable computation on these GPUs and other ideas. So it gives them the hooks to write those additional extensions as well. And we have 2 new algorithms that are common in the parallel domain, but I don't understand them too well. Exclusive scan and inclusive scan. Simple enough algorithms to pass, but I just don't have the idiom for why they're important, and I'm not going to try and talk to those. Concurrency, as I said, is just trying to get into the area of higher level abstractions on top of the traditional threading model. And there's basically a couple of proposals in there at the moment, executors and schedulers, and enhancements are built around standard future. Microsoft have the notion of the future.then method, so that could well be enhancing immediately onto the standard future class. And there'll be a few more things land in here before we have sufficient probably to say we've got a TS worth of material, but still very actively being studied in study group 1. Transactional memory I spoke about earlier. I'm racing around now, so I'm probably not going to say anything about this that I didn't say before. Key issue to be aware of is the core language feature of this has been well studied and well specified now. We've just got to the point we're looking about how this is going to land in the library. And the initial idea is we're going to pick up a few key parts of the library. So we'll pick a representative container like standard list, maybe shared pointer, and any library APIs that we require to enable transactional memory, and get that out as part of the initial feedback. So we're not going to hold the whole proposal up till we've put transactional support across the whole standard library. But if this were to move forward for C++ 17 or 20, we would really need to do that additional piece of work. So this is classic TS in action. We've picked a limited solution with the full language support and said, let's get our feedback before we spend too much time gilding the lily here and then deciding we didn't want it in the first place. Or not in this form. That's arithmetic. I said this is an existing TR. We're updating the wording to handle C++ 14 syntax, so things like constexpr, user-defined literals, and all the other good stuff you've added to the language that really help make your type feel native. And there's a question that do we ship an updated TR as a TS, or do we just fold this directly into C++ 17? And that's probably one of the big questions we'll be asking at the next standard meeting in November. So again, that should be shipping relatively soon. And final slide looking ahead, this was my tentative notion of what I thought C++ 17 might end up looking like, mostly from a library side, because most of the language features I was looking for actually landed in 14, much sooner than we expected. So I expect a bit of language cleanup, but I'm not aware of any significant language features coming through. I'm sure the evolution group will surprise me. In terms of library, I think you're mostly looking at what we've already shipped in our existing TSs, so file system, fundamentals, decimal arithmetic, possibly the parallel algorithms as well. Concepts, my suspicion is it's a bit too early. We'll get the language feedback, but we'll not have the library support in time for 17, but 20 should be a good candidate there. And a bunch of fixes. And with that, I am going to shut up. Thank you.